Hi everyone, welcome to the Car Chat podcast. I'm Sam Moores, and with us today we have Ed Bernardon. Hello.
Hey Sam, nice to be here.
You're welcome. Can you tell the audience a little bit about sort of who you are and what you do?
Well, I work for Siemens, and Siemens is a gigantic company, 350,000 people, and we were part of a little startup that they bought about 10 years ago. And I get involved in a lot of projects related to autonomous vehicles, electric vehicles, that type of thing, that brings together a lot of these different divisions that Siemens has.
Nice. So, yeah, you're in a part of a massively broad umbrella company, but how did this sort of take off? How did you get into all of this, and what's your sort of journey been?
Well, I actually grew up in Indianapolis, so I've always been a race fan, and initially worked for General Motors, the Detroit Diesel Allison division, then decided to go to grad school. And after grad school, ended up working on robots. And the first company I worked with was Draper Labs, and we were making robots to make clothes. So really, really good at like manipulating flexible materials. And we figured out that if we could apply that expertise to carbon fiber, that there'd be a lot bigger companies that could afford robots like Car and Aero. And we built a lot of machines for that over a period of 3-4 years. And then we developed this piece of software that could figure out if you had a piece of carbon fiber that came off the roll, what its shape would have to be when you cut it on that roll so that it would fit perfectly in 3 dimensions. And it sounds like a simple thing, but we grew the company. There's 4 of us that started to about 80 people. And that's really when really started getting back into motorsports by selling to Formula One teams, but also aerospace and car companies, that kind of thing. Anyone that was making things that was lightweight and fast. And then we were acquired by Siemens almost 10 years ago now. And we continue to do all that work with that carbon fiber software and design software. But one of the things I noticed when I was at Siemens is that there's all these different divisions. Like we're in the engineering software division, but there's Siemens Mobility, there's Siemens Energy, healthcare, all these things. And I found an opportunity in Boston because Siemens controls the traffic lights there, and I knew some people that were in the autonomous car business to see if we could combine Siemens connected vehicle technology with in Boston to help with this autonomous vehicle testing. And that ended up being my first exposure to this mobility division, and it led to many projects, most of which are actually in the motorsports area.
Nice. So you've been involved in so many sort of different aspects on the way through. Winding back sort of to the earlier sort of times, when you started, come up with this idea of how can we come up with some software to sort of design the right amounts of carbon and stuff like that. How do you approach a problem like that? Did you sort of look at it and go, this is an issue that I see, and then just crack on with a very small amount of people?
I think you've got the answer. The first thing is there has to be a need. Yeah. And that need just popped up. And it came from the fact that we were building these machines. Many of them were forming machines. So you'd take the material and you'd put it they were actually machines that would have like 2 sheets of rubber. You'd put the material in between the rubber and then push it down over a shape. Okay. And the reason for that is so that the material wouldn't wrinkle, because carbon fiber is not strong if it has wrinkles in it. You got to keep those fibers straight in a line. And we were constantly saying, we cut the shape wrong, or sometimes you'd make like little cuts into the material. We call them darts so that it doesn't wrinkle. And we said, there has to be a piece of software out there that does that. Seems like a simple problem. Yeah. And there wasn't. And so we wrote one on our own. And every time we'd bring people in to see the machines, they say, hey, tell us about that software you have. And and that's really how it happened. Then we said, hey, maybe we could make money doing this. And so we gave it a try. But, there was a professor actually at MIT that was working with us, and I was walking out of Draper Labs at the time. And I said, hey, I'm leaving. I'm going to start a company that figures out the shape for carbon fiber patterns. And he just shook his head and said, are you crazy? Who's going to buy that? And because nothing looks good when you first start. But, we began by selling primarily to aerospace companies. And the more the requirement for speed and lightweight, the greater the need for this type of software. So a fighter plane, helicopters, willing to pay a lot of money to do that. And we finally got to the point where we said, hey, maybe we should expand our business to Europe. And so, our market analysis was, let's go to the UK because they speak the same language or close to the language we speak. And the first trip we actually took over there was Shorts Brothers, which is now it's called Bombardier. They make planes. And the other one was to Benetton that makes the Formula One cars. And
awesome.
I remember it was the first time I'd ever been to an F1 facility where they actually do the engineering. The guy was giving us a tour. I was so excited. Actually, he opened the door. They were testing motors, and I sort of ran in to take a look. And he immediately grabbed me. All these guards, people came over and pushed me out the door and said, hey, you can't go in there. But anyways, it's, at the time, there's just like 4 or 5 of us. And over time, we grew that through a lot of ups and downs, as with most businesses, to about 80 people or so.
That's quite a big group of people to be managing and dealing with. Did your day-to-day change a lot then throughout that process? Yes.
And so there's 4 people. And I think we were really, really fortunate. I'm not sure if we exactly planned this, but we were excellent complements to each other. Now, my education was in engineering, but when we were doing this business at the Draper Laboratory with the machines, I'd taken on more of a role of trying to bring the business in. So there's 4 people. I was the head of sales and the only salesperson. And that lasted, I would say, maybe a year to year and a half. And then gradually we'd start to bring in more and more salespeople. And I think this is an interesting thing because certainly I'm an engineer, so I appreciate the technical aspects of what we were selling. And we knew a lot about carbon fiber, so it was really great to try and sell them the software when I already knew a lot about laying up composites and all the problems you have when you do that. And so we grew the business, I don't know, from nothing to about, let's just say maybe about 10 million or so. And I was the head of sales. And what ends up happening is at first you're selling. It's just me or maybe me and 4 or 5 salespeople. But when you get to the point where you have, like, let's say a $10 million company, the sales vice president ends up doing primarily 2 things: making projections with Excel spreadsheets and hiring and firing salespeople. And you hire and file salespeople quite a bit. And it really wasn't that much fun. And we brought in a new VP of sales, and then I took over introducing new products to the market. And we did that in a little bit of a different way. I've come to find out, now that I've worked at Siemens and some other places, that we would, for instance, the product we introduced first was a product for car interior design. Again, this flexible material. So we could figure out the patterns for all the pieces in a car seat. And what we would do, it was my job to make the first 1 or 2 sales. And when we say sales, it would be to the big companies like Audi or Magna or something like that. And then, and I would get my pick of I want this demo engineer and I want this product guy. I'd get the best ones. And we'd go out and do that. And then once we were able to make those sales, then we would transfer that over to the regular sales people. So, but anyways, that's a role I played right to the bitter end.
Yeah.
So it is a bit of a shift.
Yeah. I imagine with, like, let's say the carbon fiber, like when you're pitching to a Formula One team or something, what are you sort of pitching to them? Are you saying, okay, we're going to use the exact right amount of material, I guess, but then also it sounds like you're able to then really up the quality level because of all these other little tricks. Is that the sort of the move?
Yeah, it's actually both those things. One is time. Everybody wants to reduce time to market, and there's quality. So you're either keeping the quality the same and making it faster, or you're in the same amount of time creating greater quality, or both. So in Formula One, you go out and you have a race. In 2 weeks, you got to change things.
Yeah.
So you got a 2-week cycle of redesigning, then converting that into all the information you need on the manufacturing floor. And then you got to make the tooling and everything else. And then you got to make it and you put it onto the car. So the creation of the flat patterns, when we were first trying to sell these, we thought we had this great idea, and we'd go into a company, not so much Formula One, but more in the aerospace company, and say, oh, we don't need that. We have this person that is an expert at making flat patterns. And of course, we had to try and get around that person we were trying to sell. We're basically eliminating his job.
Yeah.
And sometimes it's hard for people to see when it's the first product on the market to see that it's really something that they need.
Yeah.
But what we would do is when we'd explain, hey, it's going to take less time. Your patterns will be right the first time, because when you don't have a piece of software like this, or when that creative expert is not so good, it usually takes 2 or 3 tries. You make it, it's wrong. Maybe you make some little cuts in it, darts as they call them, to get it to fit. And we would say, tell you what, give us a model of one of your parts, and we'll give you a free set of patterns. It'd only take us a few minutes. And that's pretty much how we would sell. It got to the point for a short period of time where we could sometimes make sales without even visiting face-to-face. Then eventually, other companies, within 3, 4, 5 years, some other companies got into the business too. So then things got a little bit tougher. But in the end, the fact that we understood the problem really, really well, and like I said, laid up composites and all that gave us an advantage.
And are they giving you, like, I guess with the manufacturers and stuff, they've got the CAD drawings, they send you some sort of CAD format, and then you put it into the software, boom, out comes the output.
Pretty much, they'll give you a shape, and they'll say, this is the outside edge of the shape. And now they've done all the analysis, so they know, we need, 12 plies thick, 0 degrees, 90 degrees, this kind of a stack up. And then the actual, I guess you could say, structure of the material. Is it like a plain weave? There's all sorts of different types of weaves, and they change the behavior as to how soon it wrinkles. But you get 3 or 4 of these parameters plus the shape. And then you'd put a little line on that shape. I make it sound easy, but you put a little line on the shape. I can see
there's some steps to this, yeah.
Yeah, there's a bunch of things in between, but you put the outside edge of the part, and then it sort of marches out. And here's where it gets really, really tricky, and this is why those creative people were experts, is that let's say you had a complex shape, and it has to have curvature in 2 dimensions. So like maybe a nose on a Formula One car, or nose cone or something like that on a missile or whatever. If you start at the tip top and you push the material out, or you start on the side, like the first time you contact, you get a completely different shape. And not only that, but the orientations of the fibers are different. And so structurally, the part can perform differently. And I remember when we were at Benetton, actually that first Formula One, and the guy that brought us in, he had actually made a video. Richard McCage was his name. And at the time, they used to do these side impact tests where the big weight would just slam down on the side pod. Yeah. And they never knew if it was going to work or not. And there's this video of Richard sitting outside the test room with his head in his hands, saying, I hope it works, I hope it works. And that, going back to your value question, certainly the time on creating the patterns is very, very important. But knowing that when you put that side pod into the test rig, that it's going to be okay because you know exactly where the fibers are is probably even more important.
And then most of these things, because I know for a while, lots of stuff was like hand laid, but is that done more by robots nowadays? I guess in the application it probably varies, but.
Yeah, exactly. It does vary. It depends on the complexity of the shape. So in aerospace, like wing skins, things like that, those for a very long time, like the flat wing skins, have been made by robots that lay down little strips of tape and things like that. And The nice thing about wings is they have curvature only in one direction. So if you have curvature in one direction, it works out pretty good. When you start to get more complex shapes, and for instance, the 787, the Dreamliner, that's also made with robots, but instead of tape, they lay down these little 1/8 inch wide things called toes. And the nice thing about that is they can be steered, so you can make more complex shapes.
Right. Yeah. Yeah.
But then you get into automotive. So let's take a part on the 787. It might be 400 plies thick, the fuselage. Fairly simple shape, but gigantic. So these robots, fill rooms. In automotive, even something as simple, maybe a B-pillar you might be able to form, but most parts, certainly in Formula One, there's no automation whatsoever, like a monocoque. Oh my God, that would be utterly impossible. It's all done pretty much by hand. But they do try and do things to try and keep it consistent.
Well, that's it, yeah.
So, like for instance, that if you can get the pattern to be exactly right, there's these they call them laser projection machines, and they'll project a shape onto the tool or onto the previous layer and says, place here. And it'll even give you the point on where to start the layup. Start here and push to the right or push to the left, that kind of thing. Okay. So it's made things a lot more consistent, I think. And but automation is far, far away for Formula One. So just throw a lot of people at it. That's the best way to do it.
Yeah, and train them up and get them really good. That moment you're saying of watching a large, heavy object smash into the side of a Formula One car, test car. I don't know why, I just had a vision of that, the Tesla Model X launch when they got the sledgehammer.
Oh, yes.
And the steel ball and threw it through the window and it just went straight through.
Time to redesign the windows, I guess. Yeah.
That was a funny moment. So you've been involved in these sorts of things with that company, and then you've started at Siemens. And you've been doing what have you been doing mainly at Siemens?
Well, certainly we continue this work with the software related to carbon fiber, all that, and design. But as I was mentioning before, I've gotten involved in a lot of projects that bring different divisions together. And I would say primarily our division for engineering software with the mobility division, intelligent traffic systems, that type of thing, and Siemens Energy, hydrogen as an alternative fuel. And most of my projects are related to, like I said, electric vehicles and autonomous vehicles. And I try as much as possible to use racing because racing provides the greatest challenge in a lot of these areas.
Yeah.
So it involves, it's everything from managing projects in those areas to, working with customers or potential customers on feasibility of trying to do things. But they tend to be projects that are, I guess we call them special projects. It's just another name for projects nobody else wants to do. So.
Yeah. So with the traffic study stuff, and is that working on software for lights and how to optimize that and things like that?
Well,
traffic lights and things.
Yeah. Well, there's a lot of different aspects to that, but what you hit on is like traffic light controller. So divisions of Siemens do work on that. So it can be as basic as what you just described, and those big boxes that you see on intersections that control the lights. Exactly that. I guess more recently, over the past decade or so, at least, it's become things like connected vehicles as well. Like they say vehicle to infrastructure, vehicle communication, those types of things. And that could be anything from, detecting pedestrians that are crossing a street with sensors or whatever and communicating that information to cars, or looking at the state of traffic and then changing the timing of the lights on the fly. So there's Siemens works on that. There's a lot of companies that are trying to work on that.
That's quite. Is any of that stuff implemented now?
Yes, there's certainly been a lot of pilots in Europe, in Asia, as well as the United States, in different corridors where they'll test out some of these things. They do tests on highway sections or intersections within cities. I know, especially when it comes to autonomous cars, and helping them gather as much information as they can in order to be able to operate safely. But yeah, it's out there. But it's a good point. If we were to leave our homes right now and say, hey, how many intelligent intersections are we going to drive through? The chances are you're not going to drive through one because, like as always, there's different challenges besides the technologies. Well, who pays for it?
Yeah.
I mean, I remember when we were first talking to the city of Austin and the Siemens mobility people came up here and we were saying, hey, we can help you with autonomous vehicle testing. And we showed them all this great technology. And they said, oh, this would be great. Are the autonomous car companies going to pay for that? and you can imagine, right?
Yeah.
It sort of works the other way. So it's I think that's part of it. But over time, I'm sure that we'll work it out. There are advantages. It would make streets a lot safer and a lot more efficient.
Yeah, that's for me sounds like the obvious one because I know when you look at a city, for example, and you've got all of these points of data, whether it's traffic going in that end, these traffic lights here, and we get it a lot in the UK where we have speed motorways that change speed. They might be 70 most of the time, and then they're 50 because there's traffic and they're trying to reduce flow in or whatever the pollution or anything. And I can imagine it starts off as a simple sort of like, okay, this light, if there's no one there, no pedestrians, we're not going to change it to red. But then I can imagine it gets incredibly complicated incredibly quickly as you start to connect more items into the chain.
Yeah, and it changes throughout the day, or if there's a football match or something going on.
Yeah.
In that time when people are going in and out and all sorts of things like that. And knowing that, you can start to anticipate some of these things and start to do rerouting and all that to even avoid the problem in the first place. But we had another, in fact, it's really still ongoing, a project with the FIA. And the FIA has racing. A racing division. We have some projects with them, but they also have a mobility division, which is less well known. And we did a project with them to look at the use of traffic simulation with their clubs. So they have these motoring clubs. Primarily, they've been known in the past for helping drivers, get their licenses, whatever it might be, the typical thing. But the FIA is transforming these clubs into being more advocates, not just for drivers, but for transportation in general. So we provided them with traffic simulation software for just typical traffic. And even we're looking at things like bringing autonomous cars into the simulation. But
yeah.
So we did two pilots. One was in Bogota, Colombia, and one was in Singapore. And, maybe if we introduce autonomous shuttles or this or that, things would be better. Well, wait a minute. Let's just take a step back. And how are things now? And what could you do to make them better? And what's the goal? And so usually the goal is some combination of efficiency, safety. Safety is always primary. And it seems like there's this changing landscape of scooters, e-bikes, regular cars, pedestrians, and should the scooters be on the sidewalk? Should they be on the street? What about the bicycle? Should we give them a lane? Oh, no. Now the cars are going real slow and traffic is worse. And what about motorcycles? They're sort of like bikes. Maybe you can see there's all these combinations. People don't know what to do. Yeah. So we ran some simulations with different configurations of lanes and who was allowed in them, on and on and on. And the first thing we discovered, and probably of all the things we learned in this study, it was the one that had certainly close to the top and the most impact, is in this historic district of Bogota, delivery trucks during rush hour were parking on the side of the road. And they would change a 2-lane road down to 1 lane. And massive traffic jams. And what we found out was as long as you didn't let the trucks park within, I forget the number exactly, but like say 50 feet on either side of an intersection, traffic flow picked up again. So
right.
if that okay. So wow, no autonomous shuttles, and we got 10% improvement in traffic flow during rush hour just by putting up a no parking sign.
That's really interesting. And that's a good example. Like was sort of thinking about this sort of stuff yesterday. It's Christmas holidays at the moment here, so no one's getting driven to school or picked up from school. And I was driving around at like 9:30 in the morning, and normally there would be cars, people on the way back or whatever, and the same for like 4 p.m. And the difference in the roads was insane. And you're like, okay, right. Clearly, cities are incredibly complicated. And you look at some of this stuff and you go, okay, well, the solution might be autonomous vehicles or whatever, or everyone walk, and you look at all these things and go, okay, everyone should ride a bike. But then you have to, it seems to go suddenly it gets so complicated so quickly, because you look at the entire city and like town planning and go, well, why do people drive? Because they want to drive. They're driving not because it's a worse solution. They think it's a better solution for them. And then like, how do you get these people and all that sort of stuff? It seems really interesting, the breakdown and how it might sort of evolve. And what do you think in terms of town planning? And it's very different in the US as well to the UK. Like your cities and stuff are quite different to ours in terms of mobility and different types.
Well, you're this is car chat, so you must love to drive, right? What kind of car do you drive?
So yes and no. I love driving and I hate driving. I have a couple of Porsches, and I have a little EV. So I have a little Peugeot E208. That's what I use I guess most of the use, just day to day, super easy, always charged, warms up quickly, whatever, all that. And then, I've got some sports cars and stuff. But I like driving, but I don't like driving.
Yeah, exactly. Like, so you have a sports car. Oh, give me that winding road in the Alps or in Northern California. Or take that same car and I'm going to let you go 5 miles in a 45-minute commute from my house to where I work in Boston. Oh, I'd rather just stay home, or I'd love to be in an autonomous car then, or whatever. Let my friend drive so I can do something. And I think that in a city, right, what you want is convenience. I want to be able to get to the city and get out easily, but I don't really care if I drive my sports car when I'm in the city. So there's where I think, so getting to your question is, well, okay, so how can we make movement or whatever within the city? And it's going to be some combination of different types of mobility. How do we make that efficient and safe? And so we mentioned all these traffic simulations and everything. And you could even think of it in two pieces. There's traffic simulation, and then there's predicting what's going to happen based on knowing what's happening right now. And the simulation is in there to help figure that out. One of the on these projects that we did, you would think that creating a model of the traffic in the city would be the hard part. It's not so hard to do that. To actually create a model of the streets and put the little cars on it and pedestrians, whatever it is, change a lane. It's easy to do in software. The hard thing is collecting the data. And
right, okay.
So how do you sometimes if you think about some of the things you think it should be easy to do, like they call it the green wave. Green wave is, they're all green lights. They're timed just perfectly. And let's do that for the high traffic side. Like you described, one side of the road is jammed. The other one has nothing. So give the green wave to the other side. Well, in order to have the green wave, you got to have a bunch of data. But if you had that data, I mean, look what people do on the internet based on the data they find in terms of giving us ads and stuff. How hard could that possibly be? But it doesn't really exist yet. And it certainly doesn't exist to the point where it changes in real time when the football match lets in and out. And part of that is, how do you collect the data? And so take an intersection, I think, is a great example. So when you go up to the intersection, you press that button and you cross. Now, there could be 20 people waiting to cross, or it could have been just you. Only data you can really collect is the fact that that button was pressed.
Yeah.
And you don't really know how long the people were in the intersection. you probably know what time of the day it is, but then you have to collect it in a central location, and then you have to have these simulation and prediction tools all set up. I think all the pieces are there, and we're probably getting to the point where it's somewhat of a critical mass where you start seeing more and more of that. But it's not commonplace. It's not commonplace. But it shouldn't be that hard if you can collect the information.
I guess, and then that's where these sort of connected junctions, etc., start to come into play. Because in the UK, lots of junctions have cameras now, especially in a city, whether it's monitoring the cars so that they haven't run a red light. Well, I presume it's some sort of video feed. And then you might have various street cams and whatever. So there's cameras. Now, who is in control of them is a different matter. And then presumably there's definitely some software out there that exists around recognizing people and cars, like your Tesla or something that's a lorry, that's a whatever, that's a person, that's a bird. So, but then you have all the data, of which I imagine live streaming all of that is no small undertaking.
Well, there are startups that are doing exactly what you're saying. So, and they take the technology that's used in autonomous cars. So LiDARs or radars or ultrasonic sensors. And like you said, even cameras on a perfectly sunny, beautiful day. Maybe it doesn't happen as often in London as it might in other places. But on a great day when the camera can see, it's not raining or whatever, you could take those feeds and recognize how many people are crossing the road, or this is a bus or a car, how many people are turning left, that type of thing. Absolutely. And the fact that there are cameras on some intersections probably gives a head start on that. But yeah, in some ways it's the same problem that you have in autonomous cars. What's the combination of sensors and all that? Maybe it's LiDAR and cameras, maybe radar, I suppose, but which helps when the weather's not as good. But yeah, that's exactly where you want to be. See, I'm not sure what those cameras are doing now. Are they there for surveillance or whatever?
Yeah, exactly.
But certainly that data could be used to make things better. In some ways, it is like the internet, right? You're thinking, oh, when I'm tapping on my laptop, is somebody watching what I'm doing, or are they using that information in a useful way? It's just a data problem with a physical thing attached to it.
Yeah.
And it is communication, intersection to vehicle, but it could be intersection to pedestrian, vehicle to vehicle, vehicle to pedestrian, all sorts of things. And maybe even, recognizing, oh, this person here is, disabled, or they're in a wheelchair or something like that. We'll let the intersection run longer. There's all sorts of things that startups are starting to do now, and certainly testing in cities.
Yeah, and then if you just ignored all data privacy and all that sort of stuff, like the things that like Apple do with their AirTags, which has gone a bit, I feel like it's getting a bit interesting at the moment, where yes, these AirTags exist and any iOS device near them tells you where they are. Like it pings any iOS device. Now, if you had something like an AirTag or whatever, that sort of system at a traffic light, you would know that 6 people with iPhones are standing next to it. Like you could tell that straight away. But then it's like, do you allow someone to know exactly where you are the entire time and all that? But the sort of tech side of it is quite, I think that's quite interesting, and what you could do with all of that stuff.
Yeah, it's almost, you can take things that are already invented and combine them in a different way, which people are doing, like I was mentioning some of these startups. But then how do you scale it? Cities will say, oh yeah, we'll test this technology out on this intersection and that one. And now say, okay, we're going to put it on 10,000 intersections in our city. And then there's going to always be people that aren't happy with it, maybe for the reasons that you said. So, I don't know, maybe nobody wants to be first to do it, or they want to wait and see what happens bad in some other city before they do it in theirs. But, it takes, I think it's going to take a little bit of time to, break through that. Maybe that's the key. The non-technical issues are probably bigger than the technical ones for something like that to happen. But they could transform cities. could
Yeah,
transform
massively.
them.
And I guess it's a similar thing with autonomous vehicles. And I think we should definitely talk about autonomous vehicles to some extent now. But before we do that, can we define what an autonomous vehicle is?
Well, of course, it's a vehicle that is, I guess you could say, driven or moves around autonomously. And autonomously means without the human being involved. But of course, I think everyone's heard about all the different levels of autonomous vehicles.
Yeah, was there 5? Are there 5 levels?
Yes, exactly right. So it starts off with, well, level 1 is just assistance of some kind. It's not really autonomous, but the driver's still in control, so anti-lock braking or something like that. And then you start to go some automation involved, like lane keep. We're starting to see those in cars today, like Teslas especially, even helping you change lanes and all that. But for the most part, the human is in charge. It's just helping you. And then you go from level 3, 4, and 5 is where autonomy kicks in. So 5 is fully autonomous. It's you jump into this pod or whatever it is, and it takes you anywhere. No problem. Just as good as a human. It can do everything in all conditions, right? All terrain, whatever it is. 4 is, in terms of the vehicle, still the same, but you have it in some sort, they say geofence, but some limitation as to where it can operate. And there are some 4s that are out there now where they say, hey, we got more in a test mode, but there are autonomous cars being tested between the train station and the airport or at an airport or something like that. And then there's 3. 3 is sort of a tricky one, I think, which is it takes over, but then it says, hey, I can't do it anymore. Jump in. Well, hopefully you're not reading the paper or, taking a bite out of a hamburger or whatever so that your hands are available.
Yeah.
Level 3 is, early on, I think there was a lot of companies that wanted to do level 3. I'm not quite sure. I believe Audi or Volkswagen might have announced a level 3, but it hasn't. I'm not sure if you can actually buy a level 3 vehicle right now.
I believe you can buy like level 3 ready in inverted commas. I think if you get a new S-Class, there's certain airports in Germany, or there might be just like one airport in Germany where you can get out of your car and it will go and park itself.
Oh yeah, well that's like automated
sort of
parking.
Thing.
Yes,
but like it will drive around the airport and take itself somewhere else, not just like.
Well, that would be a perfect example of level 4, right? Where you're saying, hey, go ahead, you're in control, but it's only between here and the parking lot.
Oh, wait, no. I remembered what the level 3 bit is. The level 3 is on a motorway but it's so heavily defined. It's like below 40 miles an hour on these geofence motorways, you can be on your phone, whatever, and Mercedes is responsible. But then there does have this bit, I don't know where this one fits in, where it suddenly, if they decide that they're no longer responsible, then you have to start driving again very quickly.
Well, I think this conversation is a great example of, so what exactly is level 3? Or take Tesla. Well, it's an autopilot. This goes way back.
Self-driving.
Yeah, so, what we meant was, so I think you have to have a standard vocabulary as to what these things mean. And even in the description you gave of the Mercedes, which, at a high level, I think you're absolutely right, it's level 3. But then these little things creep in. Level 3, but it's in a traffic jam, which actually is not a bad application for autonomous driving, where you're moving a little bit, 3 feet, stop, 3 feet. What a great time to just get on your phone or whatever. And then it says, hey, traffic jam is about to end, take over. Yeah. That could work, I would think. I think the dangerous one is you're on the motorway, you're in level 3, all of a sudden the car in front I don't know, brakes real hard or who knows what, and your car says, "Oh, sorry, I can't do anything about this one. It's all yours."
Yeah. Or something pulls out, or these sorts of things.
I saw there was a startup at one of the exhibitions I was at. It was actually the Detroit Auto Show, and what they had done is collected what they called edge cases. Edge cases are things that don't happen very often, but when they do, they can be very dangerous. And basically, it was videos of odd things that happen to cars. Yeah. And their business was to sell these videos of edge cases to companies that are making autonomous cars. And there's two that I remember. One was they're behind this car, right, filming it, and all of a sudden the rear tailgate pops up and this big white thing comes out. And it didn't know what the car didn't, like, what is that? Is that a little truck or what? But you would know to swerve. But most autonomous cars probably wouldn't know how to deal with that. And there was another one where a car pulled up behind this very, I would say, well, massive for a horse carriage, I guess. But it was a big white rear thing. And it thought it was a truck. But really it was a horse-drawn carriage. So now I don't know if it makes a difference or not, but maybe if it's a horse-drawn carriage, you want to be a little careful because it's horses or something. But there's a lot of things like that they don't happen very often, but when they do, they could cause a problem. And I think that one of the I think it was Uber. I think it was where at night it missed the Uber autonomous car missed the bicycle. The person walking their bicycle across, and somehow it was the angle of the lights or whatever it was. It didn't. Even a human would have had trouble with that. But the problem is, why didn't the radar detect it? Right? I mean, you would think that an autonomous car would be able to do that. But I think those are some of the challenges.
Yeah, and it's interesting. Let's say Tesla, they're doing a lot in this space, or trying, or at least talking a lot in this space. But at the moment, they're a camera-only system. And presumably, if you get to an autonomous, let's say 4, 5, you need to, if the car is in control, it needs to be able to lose some sensors and still function to a degree to stop or pull over or whatever. Presumably, that's impossible with cameras because, cameras get dirty. Surely you must need a combination of different systems and then redundancy, I guess?
Well, here's a project we did. It was actually for the FIA on the racing side, which illustrates exactly what you're talking about here. And I know if all your listeners are familiar with rally, but in rally, these cars go out and they race on dirt one at a time against the clock. Pretty much that's it. But they're going really, really fast. And if you've ever been to a rally, you can walk right up to the course. Yeah. And some people walk a little bit too far, trying to get that perfect, Instagram shot,
touch the car.
And so we were hired on this project to apply autonomous car sensors to detect these spectators that were in bad locations. Because a lot of times, especially people from the media, they'd hide in the grass, so and no one could find them, right? The marshals couldn't. And then right when the car was just about to get, they'd pop up and pop down, like those whack-a-mole things.
Yeah.
So, all right. So now you've got these cars. So what sensor should we use? There's an in-car camera, so let's just start with that. And but maybe we add radar, maybe we add LiDAR. But you have to work in this challenging environment, high vibration environment. It's at high speed. There's dirt, there's dust. They run in winter conditions. All sorts of different conditions. And so I remember some of the initial runs we did with the in-car camera. It was the Argentinian rally, and perfect, beautiful sunny day, worked great. We could detect all the spectators exactly where they were. Then one of the days it rained. There's all these people with umbrellas and stuff all jammed together. Sometimes it would think an umbrella was a person, sometimes it wouldn't. Okay, fine. And what about night? Night's real, and they ran rallies at night.
Yeah.
there's where the camera, obviously, the car's going so fast, it is overdriving its headlights to some extent. They try the best they can, but depending on the turn, whatever, that's why you had the co-driver sort of helps you in those situations. So there's a lot of cases where the camera just couldn't see it, but the radar could. The radar could. And so radar's good for that. It's also good in adverse conditions, more so than LiDAR, because LiDAR will give you a nice three-dimensional map of what the thing looks like, a little model. But radar more will tell you, hey, there's something there. And you can, not to the extent of LiDAR, know exactly what it is, but LiDAR, great in dim light and all that. But if it's snowing or raining or a lot of precipitation, things like that, not so good. Also, doesn't work so well when you're through leaves and brush.
Okay.
And in fact, when we did this rally project, they invited us to Barcelona, and we said, hey, you have freedom to go wherever you want. And so might as well test to see how many ropes we can go under, see if we ever get noticed. And most of the time, people are hiding behind leaves and brush and stuff like that, and radar's actually good for that. And so once we figured that out, then combination of cameras and radars, and then should it be short range or long range? Where do we put them? Because you can't put them on the outside of the car because, like you were saying, you get mud on them or whatever. Now it's not going to work. But you can't have them near metal parts. But on and on and on. I think that's where, like I was saying, I think that's where racing really comes in. If you can make a rally car live with these kinds of sensors in it, then you don't need that perfect sunny day in Phoenix to operate as an autonomous car. You might have a chance in that New England snowstorm or that big heavy rainstorm in London or whatever.
I mean, how on earth, that as a technological problem, like a rally car driving through a forest with people hiding and then trying to detect those people. That is quite an intense scenario that you're involved in there. Like with the radar on that, does radar go through most stuff?
Well,
I don't really know too much about other than just seeing a radar thing on with planes or something.
Does it go? Well, there's all sorts of different types of radar.
Okay.
In general, it does go through some things, but not all things. So typical radar that's used in cars now will go through brush and all that. But different types of materials have different radar signatures, like metal will have a different signature than wood or something like that. And in some cases, it'll actually go through it. In other cases, it won't. I have, actually on my podcast, there was a company I was talking to that had very low I think it was low frequency. I wasn't quite sure. It was a different type of radar in terms of the frequency band where it operated or whatever, and it could actually see through concrete. And the idea would be you could see through on a corner, you could see through the building or something like that.
Right. Yeah.
But radar does have the ability to penetrate. More so where camera is reflected light and LiDAR is reflected laser light. But the combination, right, is really good. And for us, in this case, we were looking at cameras together with the radar. It seemed to cover most of the situations. And it was funny. What would actually cause a problem when they were running in snowy conditions, rally in snowy conditions. Everything was black and white. It was this high contrast. Is that a human, or is that a funny shaped tree that's shaped like a human? It's sort of hard to tell, especially with low light conditions. I don't know. It made me think of sometimes when you go skiing or snowboarding, whatever, and it's in that twilight period, and you can't see the little edges of the snow anymore, and you start to say, "Oh, I guess it's okay. Doesn't look like there's anything big there." But it's that kind of thing. All these different lighting conditions and things, or glare. You go around a turn, all of a sudden there's a sun there. And just like it, and there's where radar actually and those types of sensors work better than a camera. But again, it goes back to these edge cases that we're talking about.
Because on motorways, I've seen it. I I've not come across it recently, but I know it was a big thing a while ago. If you go under, let's say it's a sunny day and there's a big shadow under a bridge and your car thinks that's a car as you're going under the bridge, and you'd often see, and it was like Teslas at the time, would like slam on their brakes just as well before you go through under a tunnel, under a bridge or something, and you have the car behind going like, whoop. Oh, that's interesting. But I imagine that, the software has evolved and they're now working out, okay, they can see that's a bridge. So there's going to be something underneath it. And
well, I think early on that there was that early Tesla accident, I think it was 4 or 5 years ago now, where a big white truck crossed in front of it, and the person was watching a movie or something, and it just crashed right into when it was in autopilot.
Yeah.
And I believe that the reason radar had been turned off, because radar should have detected that, even though there was glare and all that, and you couldn't really see it. But they had turned it off, I think, because it was having trouble distinguishing overpasses and things like that. So, but the nice thing though about all this, I mean, you can always pick on autonomous cars and say they can't do this and they can't do that, but even human drivers make mistakes.
100%.
But the nice thing about autonomous cars is once that one single car makes a mistake, now all the Tesla Model 3s or whatever they are learn from that mistake.
Yeah.
So the learning curve should be a lot faster. You have the collective learning of all the autonomous cars that are out there.
How? Because various companies are talking about where they are in the system, and I believe one of the big ones for fully autonomous has just stopped. Was it Amazon?
Ford. Ford actually
did. Ford?
They divested from Argo AI. There may be some other ones. I mean, there's been a lot happening in the last 6 months to a year. But Ford's probably the big one. I mean, they spent billions with a B on that, and they got out. And I remember I gave a talk in 2015. Someone asked me, "Hey, do you want to give a talk on autonomous cars?" And I said, "I guess so." Didn't know too much what they were. And if you go back to 2015, there wasn't a lot of activity on autonomous cars. And at the time, I think his name was Mark Fields. He was the CEO of Ford. And I have a slide that says, Mark Fields says in 5 years, autonomous cars are going to be on the road. And that would have been 2020. That would have been 2 years ago. And there's been a couple of CEOs, I think, since then. I think as recently as 2019, 2020, they were saying, hey, we're going to do a partnership with Argo AI, and we're going to have a mobility as a service that's autonomous. And actually, they started, I believe, at the end of last year. They predicted in July that it would be going by the end of the year. So that prediction worked really well. It's only 6 months ahead. And then 9 months later, they got out of the business. But General Motors is staying in. But you're hearing things now, like even Waymo saying, well, it's not as easy as we thought. It's going to take a little bit longer. But have you ever heard of the Gartner hype cycle? Have you ever heard of that?
No.
Do you know what that is? So
no
Gartner
idea.
is like a consulting company, and they've got this thing called the hype cycle for technology, and they do one on transportation, whatever it is, and it shows how the expectations people have for technology change over time. So when you they call it innovation trigger. Autonomous cars are launched. Ooh, autonomous cars, that's going to be fantastic. And then it goes to this thing called the peak of expected expectations. So for autonomous cars, that was like 2015, 2016 or so. And they're going to save the world. And I think autonomous cars stayed there, for maybe 2-3 years, right? And then between 2017 and 2021, it falls down into this thing called the trough of disillusionment, right? And that is when, every little accident that happens, people point at it's never going to work. We're getting out of that's exactly where we are right now. And that's a bit of, if you looked at the curve, it's a little bit, that's compressed, say. Then comes the slope of enlightenment, which is, all right, are we in or are we out? And if we're in, we got to fix all the problems. And that's what's going to happen probably over the next 10, 15 years. And then eventually, I think the last thing is called the area of productivity or whatever, where, hey, that's a product that we have. But I gave a talk once and I showed this curve, and a guy from GM comes up to me and he says, you know what, Ed, that's just like love. You meet someone and you have the first date and you get all so excited, and the peak of expected expectations, right, is when you get married and then you find out the truth. And so either at that point, you're in the trough of disillusionment. You don't like how the other person brushes their teeth or chews. Who knows what it is they talk too loud. And either you get divorced or you work it out. And that's pretty much, Ford's getting a divorce, General Motors not. So
how far do you think we are from the, let's say, the one that would make a huge difference? No, actually, no, that wouldn't make a huge difference. I was thinking, like, if I just order a vehicle on my phone, it turns up, I get in it, it drives me somewhere. To be honest, I can get an Uber that does that now, and like, it's not necessarily the best experience or whatever, blah, 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 but it's like, that's pretty good. The one that I would like is, I've got to get somewhere, I get in my car, maybe I have to drive for a bit, then I get on a motorway and it drives for like 2 hours and I can do whatever I like, and then I'd have to drive the last 20 minutes. I feel like we're not that far, technologically wise. I guess maybe that's the two sides of it.
Well, on my Future Car podcast, it was actually the last one we did this year, I had a lead technology officer from that company talk about their autonomous shuttle. And this is a classic question, like, when can I have a ride in one?
Yeah.
And he said 2 to 3 years. I said, wow, this is great. I'm going to be able to ask this guy all sorts of good questions. But his point was that the key is to find the right path or where you want it to actually work. And for instance, between the subway and the airport or whatever it might be. His thought was the key is to get people to feel that they're going to be safe in it. And also, if it is a shuttle or something like that, the concern was privacy. Like when I get in there, I'd like to have my own little cubby hole or whatever. The highway's an interesting one. You hear a lot about trucks and platooning, where the front truck is driven by a human and you got a bunch behind it. I don't know of any major pilots that are between cities. Not that's like take me from Stuttgart to Munich or something like that. I guess a pilot like that gets a little bit more tricky because you're under a lot of different jurisdictions and things like that. But there was this guy, Bob Lutz. He used to, I think Bob Lutz, former General Motors, and he had this vision of these chains of cars, right, on the highway going like 150 miles per hour. So you would get in, manually driving your car, and you'd bring it up to 150. The chain would split. You'd slide in, click. It's not mechanically connected. And then then you would do exactly what you want to do. You're sitting in there, and when you're ready to depart, the chain sort of opens up, and you take it to the exit. I mean, in a way, that's in some ways there could be even a human driver in the very front one. Who knows? So like a train, a virtual train on the highway, I guess.
If something like that, if that sort of thing was possible, whether it's, there's 3 lanes and the left lane or the right lane, whatever it is like, it's one speed, you just kind of like lock in digitally, and then you just, it keeps distance. It knows what the other cars are also doing. It has some idea of what's at the front. Then there's no reason why that's not possible. It's possible today, but whether you'd be allowed to do it. And I guess the key point with all of these things is like, who's responsible? Who's liable if it goes wrong? Because all the systems at the moment, I don't think anyone, in at least like most cars, your driver is responsible. driver's liable. Anything goes wrong, it's your fault. It's not the system's fault. You were meant to be driving. When that switches over to a manufacturer, and like, is it then on their insurance? And like, there's probably a huge gap between those two, between someone sticking their neck on the line and going, "Yep, okay, we're responsible now."
Yeah, I mean, and there's probably a lot of layers to that, at least several layers. There's the manufacturer. It could be the software too. I mean, the manufacturer and the software provider might be different. There's the owner, I suppose, or if this autonomous vehicle is operating in a gated community or something, maybe it's their fault because they're providing, like, whose fault? Yeah, I think it seems like it would be, the thing that's great about that is if you're a lawyer, there's plenty of customers and a lot of people you could sue, it seems like.
Yeah.
But this applies to a lot of places where AI might be. Is the machine truly independent or not? Truly independent or not? Because one could say, well, I programmed it, but I didn't program it to take that right turn, and hit your cow or whatever it is that it did and cause damage. I just programmed it to, follow all the rules the way they're supposed to be. It's the car's fault, right? And there's this notion in law of remoteness, and how remote is it? And it actually goes back, surprisingly enough, to the days of the Romans, where someone would own a slave, but they weren't responsible if that slave did. Okay, does that apply here to autonomous cars?
Yeah.
And then there's the whole thing about what's the right decision to actually make. It can get a little bit tricky. Have you heard about the trolley problem? Have you ever heard of that?
Yeah. Someone pushes out a baby or whatever, and there's an old person. And
exactly, right. And MIT did this thing called the moral machine. Have you heard about the moral machine?
No.
It's the trolley problem on steroids. And you go in, and they present you all these combinations. Woman with baby carriage, criminal. Whatever, doctor versus baseball player, and on and on and on, and thousands of people have taken this thing, and eventually it sort of filters out. And it's surprising the number. You're the safest if you're pushing a baby carriage. No one wants to hurt anyone pushing a baby carriage. And then things like lawyers are below sports figures, and at the very and criminal is almost at the bottom, but the bottom three go, the highest of the three is dog, then criminal, and the lowest is cat. So people will run over cats before they will run over a criminal. But you have to make a lot of choices, and these are pretty high level choices. And I suppose you have the same problem with a human driver on some of these things as well.
And then, but at that point in time, it is the human driver. I guess the human driver is the one that's made the decision. They've chosen to run over the old lady rather than the pram, and then they find out the pram had a dog in it, or worse, a cat. And then you're like, oh no, I should have killed the cat.
That was number 14 on the list. Instead, I went after 15. What a mistake.
But humans are incredibly good at, I feel like, making decisions like that very quickly. I had one, it wasn't exactly this scenario, but I was driving down a road in London. It was a 30, I was going 30, and I was sort of heading straight ahead, and there was a turning to the left, and there was a big van on the left. It didn't see me and pulled out, like the full length across the road, so it covered both the lanes, mine on the left and the lane on the right. And I hit the brakes and knew straight away that I wouldn't stop. I was not going to stop before making contact with the vehicle. And then my brain went, right, where's the exit? And there was a gap between like the back of the car and a parked car. And I managed to like slam on the brakes, screech to a halt about a car length behind the back of this truck, missing a parked car on the back of the truck by like not a lot. And they're going, and the person was like, oh my God, I'm so sorry. But like in those sorts of situations, humans are quite good at making a reasonably good decision. Now, driving, maybe you need to have had bit more practice about driving so you don't freak out so much or whatever. But like we are quite good at those really complex, very quick, lots of input decisions.
I think you're absolutely right. And you have to think of it, though, I think in a slightly different way. Because the situation you're describing, if it would have been an autonomous vehicle, say, instead of you driving, it's an environment where you have humans and robots interacting and working together, right? So in this particular case, your truck that pulled out, my guess would be an autonomous car tends to be really, really careful. It probably wouldn't have done something stupid like that. Because humans, you're absolutely right. Humans would be really good to react to those situations, but also humans make mistakes that probably an autonomous car wouldn't make. And it's those mistakes that truck did that almost caused an accident. So if you could magically say nothing but autonomous cars, things might be really slow because they can't make decisions and things like that over time they could improve. But I think it would get safer because there'd be fewer accidents to avoid.
Because I could have been driving a bit slower. I was going the speed limit or whatever, but I could have been driving a bit slower. And now, like having had that experience whenever it was, 10 years ago or something, whenever I see someone, and this is something that I guess you'd sort of program it in a different way. As a human, if I see someone waiting to pull out, I kind of try and like see if they've seen me. You know, you look at them, and if they'd looked at you, and a car probably won't be able to see that, like not for a while. You know that they've seen you, and then you can carry on as normal. Whereas if you don't think they've seen you, you have to act as if they've not seen you and then slow down. So an autonomous car presumably is going to have to take in, if those two can talk to each other, fine. If the one that's parked, it's not going to it shouldn't pull out because it's seen the other one. But there is going to be that leeway point, isn't there? I like the idea. There's going to be this middle ground, as you say, of autonomous cars are going to have to be really lenient. Does that mean they're literally through a city where it's busy and everyone's pulling out? You're just never going to get anywhere because all the people not driving them are just
It's like having a city full of polite drivers.
Exactly.
And, no, you go. Oh, no, you first.
Like, go. Yeah.
Well, you know, so I grew up in Indianapolis in the Midwest, and then I moved to Boston. And the driving is completely different. It is the racing capital of the world, but on the streets, we're like normal people. Come to Boston. And it was the first time I come to the city. And for us in the U.S., a left-hand turn, you wait for traffic to pass. And then, not in Boston. In Boston, they have the Boston left-hand turn, which is like, hurry up and go before the car's on the other. I said, wow. And a friend of mine said, watch what that car does. And I couldn't believe it. And the same thing when you go into a rotary or roundabout. They said, never look at the people that are in there because that takes away your right of way. But it's exactly what you just said. And they are trying to do some things with autonomous cars. I think there was one company that put like little eyeballs and a smile on the car. I don't know if it was, as an example, but certainly like printing things on the grill or whatever. But more importantly, going back to what we were talking about earlier with connected vehicles, it could be a connection between the car and the pedestrians that are at that intersection that says, oh my God, there's a car approaching at a speed in which it can't brake. And it might be able to give you more than like, a millisecond or half a second of warning. And you can not step off the curb. But again, that's the kind of thing that's the kind of communication you'll be able to get.
Your phone could buzz as you're about to you've got your headphones on, listening to music, and you're just about to step out in front of a bus, and it could go stop.
Yeah.
Yeah.
Why not? Right?
Why not?
Well, that's better than trying to get the attention of the bus driver. Hey, I'm over here.
One of these will kill the other one.
Well, there was another shuttle company called Zoox, and I interviewed their chief safety officer, Mark Rosekind, and their whole thing was preventative safety rather than reactive. So preventative is knowing there's an accident about to happen, do something now so that it doesn't really happen.
Yeah.
So that makes a lot of sense, and AI should help you to do that. But sometimes I think, we fall in love with the sensors and the AI, but there's still the vehicle itself. And what they did was, in their little shuttle, they put really oversized brakes on it so it could stop faster. Wow, that's a great idea. That buys you a quarter of a second or something. A quarter of a second is a long time. They also put in four-wheel steering. So if you want to turn left, the front wheels turn left and the rear wheels turn right, so the turn radius is less. And you combine those three things, I don't know, maybe in certain situations they all add a quarter of a second, and you end up with 3/4 of a second more reaction time. And if you think about it, that's really a long, long time at an intersection when somebody just jumps out in front of you. Or even the classic one, I know when we first started working with Siemens Mobility, I asked them, and they had these sensors at the intersections. I go, what's your top thing you detect that causes accidents that you can solve? And it was, when you have a lot of parked cars and you don't go to the crosswalk, instead you cross in between parked cars.
Yeah.
No one expects you to be there. Suddenly there's a human where there wasn't one. And he said that causes a lot of problems. Or people opening the door into the bike lane. Maybe there could be a thing that keeps you from opening the door if it detects a bike somewhere. I don't know. But
there's definitely, I've experienced various things with those ones. Like in Belgium, if everyone learns when they're doing their test and whatever, and it's just drilled into everyone, that you open your door with the other hand. So if you're on the left-hand side of the car, you open your driver's door, but you open it with your right hand. And what that means is you have to look back before you open the door. And also you can't open it very far. So you open it a little bit, then you look, because they've got loads of bikes. And that, everyone does that there, or it's a very common thing. And that reduces, you don't need a car to tell you or anything. It's just changing human behavior slightly. And you're way less likely to open a door onto a bicycle.
Do you do that in the UK?
I don't open the door with my left hand, but I never never swing a door. I always crack it a little bit and look and check, and just a tiny bit, just a little bit, and then see, because
it's a great idea. I'm going to try that. I'm going to try it. I think it would work.
The other one of a similar sort of thing that I've experienced, which was really good, was driving in Sweden in the winter. So just snow everywhere. And the car I had was a new Bentley Continental GT that had thermal cameras. And it had the thermal display that you could set up on the dash in front of you. And you're driving in the countryside, and the main problem there is all the animals in the winter, whatever they are, reindeer and stuff, jumping out in front of the car. And it's a very real problem, and it's the same sort of thing you get in Australia with kangaroos and things. They just love jumping in front of cars. But I felt so much safer with a thermal camera, especially in winter. It's freezing cold, and then you can just see, bang, there's an animal in the bush somewhere. I can slow down, or there's nothing. That was transformative at driving at moderately quick speeds in the winter.
Yeah, it's the sensor helped you. I mean, it's
big time.
In some ways, if you think of this autonomous technology, and I think Toyota originally had this, and now there's a lot of companies thinking along this way, is to use the sensors not to create autonomy, but to create what they call a guardian angel. So it's doing everything an autonomous car does, perception and potential path planning, but it never takes control unless you do something really bad. And then the guardian angel swoops in and saves you from a terrible accident. And that's a great application. Probably would make the most sense, because it'd be a long time before there's a lot of autonomous cars on the road. But all the technology that's been applied to that autonomous cars could now help with that. And in some ways, that's what Ford's doing. They're going to be applying what they've learned to ADAS, to driver assist systems. And that's probably one of the greatest ones, keeping you safe from accidents and all that. But I wanted, though, to mention something came to mind when you talked about the bicycles in the door. And I see this the most in Paris of all European cities, is you're on the motorway and traffic slows down a little bit. All of a sudden, there's all these motorbikes like going down in between. And I'm thinking, I think the Parisians or the people are used to that, and they wouldn't dare suddenly change lanes. Oh, but if you're a Boston driver or whatever, not used to that, you might want to try and inch your way into the third lane, and then you're going to block off the motorcycle. And I don't know. It seems like there's ways of even detecting those kinds of things that could.
And they are like, I've had it in London, where you're driving along, you're in the left lane, you're turning left, and you're like, I'm about to turn left. Generally, cyclists are moving slower than cars some of the time, unless you're slowing down, then they move faster. But I was about to turn left. There was like not very much space next to me, just about to turn left, and a motorbike went past, like straight past at like 40 or something. And you're like, oh, wow. And I didn't see them. And I feel like I hesitated for some unknown reason or whatever, or just hadn't quite got there. But there was literally a split second of I would have been turning left and they would have just gone straight into the side of the car. And you're like, that's not my fault. But it's not massively their fault. But at the same time, it gets complicated, doesn't it? And it's kind of down to the individual, but then you get an outsider or something in, and those scenarios get different. It's tricky. It's really tricky with, I think, fast-moving, especially motor-powered bicycle, like motorbikes and stuff, and scooters in cities, because they do go quite a lot faster than the traffic.
Yeah, and the more of this mix of vehicles that you get, because that's a mixed vehicle problem, but it's a mix we've always had. And now you get e-bikes. Well, an e-bike, when it's at full speed, it's like a slow motorcycle. Yeah. So it's a gray area where it's a motorcycle, but it's really a bike. And then you have scooters. And should the scooters be on the sidewalk, or should they be? And if they're on the sidewalk, then they're weaving in and out. And not to mention when they park them, they fall over, and maybe they're blocking the bike lane. And then eventually, you have this melding of the street with special lanes, more and more special lanes. Then you have sidewalks. There's no rules on the sidewalk, right? I mean, and now and then you're going to have, everyone talks about last mile delivery and all that. Well, okay, so the FedEx truck pulls up, and these little sidewalk drones go out, and they're going to be able to navigate going in and out of buildings. And eventually you're going to be there, and buildings will be designed so that they don't discriminate against the last mile robots or whatever it might be. But then you need to have laws or regulations or something to regulate how all this works. It's hard enough to regulate with the mix we have now, which is what you were describing. Yeah. But ultimately, that's going to be a key part of it, is to what are the rules of the road going to be, and they have to evolve with the technology, or else you're going to have some problems. Yeah. And then it comes down to, as we were talking about before, the blend of how you structure towns and cities, and whether you allow cars in, really far in, or actually they're sort of relegated to the outskirts a little bit. It's difficult if you live inside, but predominantly most streets could just be bicycles, scooters, walking, with some car access at very slow speeds for certain reasons or whatever. But it's so complicated, and I think as humans, we're really bad at accepting that it could be better. You see it in certain places; they reject it. You can get comfortable with the way things are.
Yeah, Like Amsterdam, I think is a good example. It's a lot of cycling in the center and you can't drive through certain bits and they've got a ring road and whatever and stuff like that. But there's a few places in the UK, Oxford and Bath, I think at the moment are considering, Oxford are doing it quite a lot, where they are just chopping access to cars, just going like, nope, you can't go through there anymore. And then everyone's, rightly so, I think, pretty annoyed about that because they're fundamentally the way they do their life has just been completely changed. But then you sometimes find, definitely with like the Belgium stuff and Netherlands and things, where they make this change, everyone hates it, and then 5 years later, it's the best thing on earth, and they love it. But how do you do the gap?
Yeah, and maybe you don't have to do it everywhere. You do it in a section of the city or whatever it might be. But you're a driver. You have a sports car. I mean, I like to drive too. But if I want to go into Boston, I hate having to find a parking spot.
Yep.
And then I'm in one section of the city and I want to go somewhere else. And Boston's not even that big. I mean, Manhattan or a large city like that would be much worse, right? Where, it's 3 miles away or 5 miles away. Should I walk or should I? I'd have to park again. So I think that you have to look at all these pieces together. I remember one time we were in downtown Boston, same kind of situation. We had to go a little bit farther than we normally did. We said, well, let's walk, but it was raining. And there were scooters and e-bikes that were right there. It was really raining. Yeah. But what if there would have been a little 2-man electric pod, real teeny one? It probably wouldn't take much more room than 2 bicycles side by side. Yeah. And it could have hopped in that and just drove it, to the place I wanted to go. And I think it's that mix of vehicles that if you look at all the possibilities that you could have, and it's not just pedestrians and scooters at one end and autonomous shuttles at the other end, it could be little electric cars.
Yeah.
Or is it a car or a pod, a one-man pod, whatever it might be. And there are companies making those things. Or little shuttles that don't go more than, say, 30 kilometers per hour or 25 miles per hour, that you can hop on and off and it drives in the bike lane at the speed of a bike. And if you have those vehicles, if you could make a city a clean sheet, you could probably design for this mix of vehicles. And then if you think of what we were talking about before, all right, I can't drive into the city, but that's actually okay because I parked on the periphery and the little 2-man electric pod picked me up. Maybe it is autonomous, in which case I'm just looking at my phone to figure out where I want to go and have dinner or whatever. Yeah. That wouldn't be so bad.
I think a lot of people look at the car as freedom and they go, yeah, but I can get in it, I can leave stuff in it, I can take it wherever I like. But actually, freedom in a city is the ability to go where you like, when you like, and not have to park. And if you want to have a beer, you can have a beer, and then you're not like, I've got this car, so I can't have a beer, or like, and parking. I think people underestimate how much time and effort and money you lose parking cars.
Not to mention the space, right? And they could be used for something else.
Isn't it some insane percentage of traffic I think it's in London, but it's something like 30% or more is people looking for parking spaces. That's just what a lot of the cars driving around are doing. They're just looking for a parking space. Like,
I remember you could probably find it online, but it was how much space in Los Angeles is dedicated to parking. And it shows a map of the greater LA area. And then there's this big, gigantic square in the middle of it. And you said, oh my God, that's a lot of space, right? That's being used just to park cars. I'm not sure if they were counting the cars that were actually stalled on the highway due to traffic as being parked, but there's quite a few. There's quite a few that are, if you could do that, I think. Your freedom thing is a really good point, because when we began with our startup, and this is going back into the late 90s, early 2000s, if I would travel somewhere, rent a car, and then, especially if I went to the UK, then I'd have to instantly learn to drive on the left-hand side. But you'd have this thing that you had to drive and park, and And now I hardly ever get a rental car if I'm on a business trip.
Yeah.
Always Uber, because it's like you said, it's liberating. Take me to the
is.
hotel. All right, now I want to go to the meeting or whatever it is, and it's just easier. It's just easier.
It is.
And if things become autonomous or there's other forms of transportation, it adds to the efficiency and the ease with which you can do it. Like that evening when we were sitting in Boston, regardless of the weather, if you're not taking an e-bike or a scooter, you can get into two-man pod. What about when you get in that two-man pod on a sunny day? When if you don't like being on a scooter, for instance, but it's all part. You just want to get from A to B as easily as possible. But hey, now let's have a few beers.
Yeah, exactly. And I was just thinking about it. Like we have these like sort of city cars that you can rent for. I can't remember what the companies are called, but you can rent a car for 20 minutes, and generally you can park them. Like in London, you can park them pretty much anywhere, any residence bay. They've done a deal with the councils, so you can pick up a car from somewhere near your house, drive it. You just pay for the time you're driving it, and then you can park it up. And we have some dedicated car club bays. Like I've got one on my street that's got a little Peugeot E208 or something in it. And you can go and rent that car for half an hour, 45 minutes, an hour. Now, with EVs, I've not seen it yet, but that parking space could have a charge point. And you could literally, when you give back this car, you just plug it in, and then you've got a car that's got probably a full tank, a battery all the time. And then you're like, okay, if there's a few of those on my street, how often do I actually use a car? You're going to get a lot more people like that who go, maybe I don't need to own a car. If there's always a car available when I need one, then maybe I don't need to own one. And it depends on what your city in.
Yeah, or maybe you have just one that you keep. Yeah, that's not that expensive to keep, that you keep for the long trips or when you want to tow a trailer or something or whatever it might be. But yeah, absolutely. And there's where I think those small EVs might come in handy. There's a company here in the Boston area called Indigo, and they make these little electric vehicles. Have you heard of Indigo? Little electric vehicles, 3 wheels, and they took the suspension and the wheel and they have wheel motors. So all the suspension wheel motors are right where the wheels are, which makes, although the vehicle's small, it still has surprisingly a lot of room inside. And his target market is the gig economy, to do exactly what you just said. These things are lined up. I'm going to deliver sandwiches this afternoon, or I'm going to be an Uber, and I don't have the overhead of having to own my vehicle or maintain it or whatever it might be. But you're right. If one of those little Indigo 3-wheel cars was right down the street or not far or in a big parking lot that I could drive to in my town outside of Boston, I wouldn't mind taking one of those in. Why not?
Yeah, especially if you can then park it anywhere. Like with these ones, you can pretty much park them in any residence bay, which is a lot easier than parking, which is, I don't know when you have this where you are. There's like, we have a zone that's like, whatever, couple of blocks that is our bay. We can park anywhere in that area. And then outside of that, you're not allowed to park. Whereas these things, they can park anywhere in those. It just opens up the possibility.
Well, your point is a real good one, which is a preference for certain types of vehicles. And what's that preference really based on? And one thought is, when you're traveling in a city, you're actually renting space on the road for a certain period of time. So if you could say, all right, we're going to charge you by the amount of time and space you use. So if you've got a vehicle that's 1 square meter and you use it for 1 hour, it's 1 hour meter squared of cost. Now, if that same person drove an SUV, a big, Cadillac Escalade in, they'd cost them 10 times as much. And then you could even start to do things like, well, if it's electric, we're going to give you a 50% discount. Or maybe you don't want them to drive on certain roads because, and you have time, hey, these roads here are 25% less until 4 p.m., on and on and on. And then I think by doing that, you redistribute traffic. You'd if you have goals of providing transportation to certain areas of a city where it's not served properly, that kind of thing, or emissions. But in the end, okay, you want to drive your Cadillac Escalade into the center of London just by yourself? Well, then you're going to pay a lot of money. Yeah. But why should the person in the little smart car, or maybe even a one-man pod, pay exactly the same as the person driving that, right? And, we talked early on about data. It's that kind of data is what you really need. Okay, this signal signifies a one-man pod. This signifies a large SUV. As you enter the gate, it automatically charges you or whatever it might be, or gets the clock ticking for that time per square foot charge.
I think it would be really interesting to have that. I don't know whether I necessarily want that, but I like that sort of system, whether it's like, if you've got a massive car with one person in it, you don't need that. So there should be some penalty for operating a massive car with one person in it. If you've got 7 people in it, then it's 7 people, then fine. That's okay. But yeah, we should. And these things, I think it's really interesting how these things are going to evolve. And I'm heavily involved in the car market, but I like all the different solutions, and it's better. If I could cycle everywhere and it was a really nice experience, I would rather cycle. If it was a nice experience to do and I could drop my bike off and it wasn't going to get stolen and whatever, or I rent one and it's easy and they're well maintained and maybe they're electrically assisted, that sort of stuff. If we can make it easier and nicer and better, people will just change their habits. You're not forcing them to change their habits.
Yeah, it's carrot versus a stick.
Yeah, exactly.
Well, and you, as drivers, as people that like to drive sports cars or enjoy just the idea of driving, I think you have to split those two worlds. I enjoy driving, and I just want to get there because what I really enjoy is what I'm going to do once I get there. In that world, all these combinations of vehicles or whatever, hey, I'll put up with the lower cost electric, small footprint vehicle that brings me into the city. And on the other hand, you can't always be by that beautiful Alpine road, where you can drive your car. Yeah. So I still race go-karts with my son.
Nice.
And I don't know how many races in a year, maybe 10 or something like that. One every month or so when the weather's you can do it. And it's really great for just getting that, now you're wheel to wheel and you can cut people off, or I don't know, maybe that's not the right thing to say, but you're out braking into a turn and you're at the limit, and hey, sometimes you go off or whatever. But if you really like to drive, those are the kinds of things I think that you have to look for, and keep those two things. There's transportation, and driving will become it'll tend, as autonomous vehicles in this world we're trying to create here becomes reality. Driving will become like a sport, just like riding horses is a sport now. It didn't used to be.
Yeah, and I on that one, I get, the more track driving I do, and I do some racing and stuff like that, the more I do of that, the less. I definitely don't drive anywhere near as fast on a road now, because it's a different experience, and I know that I can't push, like you say, in a go-kart or whatever, that you're flat out. You're pushing hard, and if you come off or if you slide wide a bit or whatever, it's fine. You can't do that on a road. You can't do it. And once you've done it in a car or whatever, you have to be aware that on the road is different and it's not the same. So don't try and make it the other one. You have to distinguish between the two and just accept that this is the situation and enjoy it for a different, whether it's the view and the sounds and the feel and whatever. But trying to maximize your cornering G on a single lane road.
No, you're right though. It's you got to get your fix of G forces and potentially sliding out and what it might be. But I had a Honda S2000. It was a 2000 Honda S2000.
Yeah.
And it's practically like a go-kart. There is no traction control or anything like that. And not just saying I actually did this. It might have been somebody else driving my car. But when they came off the motorway, you know how you have like a tight, we say like a clover leaf. And, how fast can you actually go on that and brake at the very end when you get on the end?
Yeah.
I could probably, a Honda S2000, I don't know, 50 miles an hour, but you're on the edge, right? You're on the edge. And I have a Porsche, a Boxster, and it has traction control and this and sport mode. And I don't know, a grandma or anyone could take that thing and drive it at 60 miles per hour on the exact same road. And it's like nothing. It's like, so for that, in that mode with the suspension and everything set up in that way, you would have to drive it at 80, or I don't know what the number is. I don't dare go that fast. But, So, anyways, and so if you want to get the joy out of that, you have to do that on a track, I would think.
You do. Or I think a lot of people now are going, definitely in the car, amongst people I know anyway, they're starting to gravitate towards older vehicles with less grip because of that thing. Like, if you're on the limit at 30 miles an hour, now there is a point when it gets, stupid. If you're on the limit at 5 miles an hour, maybe on snow, that can be quite fun. But at the same time, 5 miles an hour on a dry bit of road, it's possibly a bit slow. But if you're on the limit at 50 or 40, that's fun. And you're not speeding. And if the consequences are nowhere near as bad as if you're going 80 miles an hour, you're not going to travel so far if you do come unstuck.
Yeah, and I think that's probably the thrill of a go-kart, because it's not going to go nearly as fast on the straightaway, but then you don't slow down that much in the turn.
And you're like fully in a go-kart. Most people are fully committed. I think you're like on it and you're like, okay, yeah, it's moving around a bit. Okay, I'm going to dance it on, or if it's wet or whatever, you learn a lot. Right, well, I normally wrap these up with 5 questions. Are you ready?
I'm ready.
Do you have a most memorable driving trip or journey?
I'd have to say, so my parents come from the Friuli, which is in Italy, south of the Alps, and we were in Munich, and we drove from Munich to Pordenone, which is a town in there, and to do that you have to drive through the mountains. Sometimes it's tunnels or whatever, but when you come out of those mountains, and we stayed away from the motorways, that was one of the greatest drives. And part of it was these windy roads going up and down mountains and all that, but sometimes you just sort of stop and look at a vineyard or something, or maybe it was like some cows by a fence. I don't know, whatever it was, but I'd say that was probably my most memorable drive.
Yeah, there's those sorts of drives. I've done lots of sort of Alpsy parts of Europe from various countries and whatever, and that's it. Like, I think the thing I sort of forget when I've not been in a while is just the scenery. I guess fun to drive the roads. That is fun. But then, like you say, when you just stop and you just take it in, you're like, wow, no, this is really cool. Just like,
look, a cow.
Yeah, exactly. If you could only drive one sports car, for the rest of your life, what would it be?
That's a great question. And, and I think about, I still have the S2000, and then I have this Boxster S. And if I had to pick between those two, I would pick the S2000 because of what you were saying. You have a connection to the road, and you can feel it, and it's not as forgiving. You have to know how to drive it. So I would, it would be something like the S2000. But you know what? I'd have to take like a Ferrari California from maybe, that's the one from Ferris Bueller's Day Off. But I think they go for like $4 or $5 million at least, maybe more now. I don't know.
That would be very nice.
I think that's very nice. What would you take?
I would. For me, it would have to be some sort of 911. So I have a 997 Gen 2 GT3 RS. It's like wing, manual, stuff like that. And that's pretty good. It's not like super modern by modern standards. So what is it, 10 years old, 12 years old now? But that's possibly too capable. I think I would possibly even go older. So like maybe like 993. So what's that? 2000, early 2000s. So like less capable, bit older. You feel a bit more, go a bit slower, but less grip. Something like that. And then I could do everything with that. I could put a kid in the back, luggage, whatever. So something like that for me. What do you think is, and this may not be a particularly a strong one for you, what do you think is the most undervalued car at the moment? What should be worth more?
Oh, undervalued. That you can buy today, or like from...
As in technically buy, as in you might maybe used, maybe new, but like should be worth more.
Well, that's a good question. A friend of mine bought a convertible Camaro GT, like with the two white racing stripes on top.
Yeah.
And he had to do some work on it because he borrowed a bunch of tools. And I said, "Wow, how much did you pay for that?" The body was in perfect shape. And he said $50,000. He said he'd been saving all his life for doing that. Is that undervalued? I don't know. I don't really know. But I would think, I'd have to think about that a little bit. But for me, I would bet that there's some like old British, convertible or something like that.
Sure.
I've always had convertibles all my life, so I like the 2-seater convertible. That I bet if you pick the right one, that no one is really, less popular. There's got to be something out there that. But then, of course, you have to put up with the fact that if it is one of those British ones, that it's going to catch on fire or something.
Yeah, exactly. It's got a roof, but it might as well have no roof. The same amount of rain gets in. All that sort of stuff. What is the most interesting car or interesting car tech car for you at the moment?
That's most interesting car tech. That's a good question. Well, certainly there's all these driver assist systems and things like that. I mean, some of those are to make it easier to drive. Some of those are like lane changing and things like that. There's all this connected vehicle technology that you're starting to be out there. You know what's really interesting, I think, though, is the ability to update cars on the fly. And certainly there's the software part of that. But I think it's interesting in that if you load in all the hardware in a car and then only turn on what you pay for. So for instance, like the heated steering wheel, being able to have that only from December to March, and the air conditioning, the other part. Or I want to try out, the super sport mode or whatever it might be.
Yeah.
I think that has the potential to really make driving fun. Because when you buy it, now you're stuck. I keep cars a long time. You're stuck with that setup for 10 years, right? So I think that's probably something that would be interesting. And then when you buy a used car, you could even reconfigure it to have the options that you want in it.
The manufacturers would love that, wouldn't they? I think there's a really fine balance with some of that stuff. We're hearing a lot about that's in the news at the moment, whether it's like BMW have said, you've got to pay extra to have your heated seats or whatever. I think if it's all priced in at the beginning, so like you're not paying more to have this stuff, even though you've got it, but like you haven't got it. And then it seems the idea of floating like a subscription for, I can't remember who it was. Someone was talking about performance. Was it Mercedes maybe? Who was saying you could pay $1,000 a year or whatever it is, and you could have another 100 horsepower. And you're like, okay, but then do I have to pay that every year? Or do I pay it once and then I've got it? What if I sell the car? Do they get it? No, they don't get it. Like, there's all those sorts of... I think it'd be interesting to see how that develops. I'm a bit wary of it. If I've bought it and it's in there, I kind of want it there. But then cars could be cheaper because of the logistics. If they're only making one car, ish, rather than 50 combinations, then that car should be cheaper. And actually, you're spending less on the car in the first place. So if you spend a bit more to have the options you want, then that's probably all right.
And then there's another aspect to that. Henrik Fisker, he's got his new Ocean SUV, and his pricing model is, I think it's like $3,500. You're in, and then you pay $350 a month. Turn it in anytime you want for a new one.
Yeah.
Boom. Okay, I'm tired. What do you got?
It's an interesting idea. I think if you had, like, let's say you had one car, but you had it on a monthly fee, and people might do that anyway now. Like lots of people do. You pay, I've got a car that's on a monthly amount. But if you can then change it out for a bunch of different cars within the same price bracket or whatever, and you go, okay, well, at the weekend, I want a sports car. During the week, I might want a small city car. And then 5 times a year, I might need a big vehicle that I can put all the family stuff in, but not have to buy 3 different cars or 2 different cars. I think that is quite interesting if the economics can work and whatnot.
Yeah, and you go online and you select it, and it autonomously comes to you, and your other one goes away. Make sure you take all your stuff out.
Yeah. Yeah, I think there's a few companies that are trying. I think Volvo tried something like that.
Well, but I think, though, that's a good point. It's this whole freedom of having what you really want or being able to do what you really want to do. And maybe you could even say at any point when you find your dream car, you can convert it over to permanent ownership.
Yeah, exactly.
It's a great idea.
No, I think, and it's interesting to see how these things are going to evolve. Right, final question. 5-car garage, unlimited value.
Oh, wow. Well, okay. We'll start off with that Ferrari California.
250 California, yeah.
Yeah, definitely. Then I'd want a Porsche Carrera GT.
Nice.
Definitely would want that in there. Then, let's see. What else would I put in there? I think I'd like that Jaguar E-Type. I think I'd want one of those in there. Then, let's see.
What's your sort of day-to-day car?
Yeah, you're right. I have to live with these cars then, right?
You do, yeah. And you only have the 5.
I only have the 5. So I think I would want some sort of a pickup truck. So, because I have to tow the go-kart trailer or something like that. So, you know the Ford Raptor? You know that Ford? I really like that. But I wish they would make it a little bit smaller. Like shrink it down to like a mid-size one. Yeah. Like the Ford Ranger Raptor. I would have one of those. I'd have one of those in there. And I have one more, right?
One more.
Then I would pick some sort of a really nice, why not have like, since I can have so many, I'd probably pick some sort of luxury car, I think. But then on the other hand, I mean, you could have a Bentley or something like that, but maybe that could become boring too quickly. I'd probably pick some sort of high performance, some sort of, like an F40 or something like that, a Ferrari F40.
Nice.
Maybe a high-end Porsche or something, but I think I'd stick with something Italian. I'd have to go with heritage.
That'd be a good bunch. You've got a lot of bases covered. You've got your convertibles. You've got an old convertible. You've got a new convertible or newish. Yeah, it'd be good. Cool. Well, thanks very much for coming on the podcast.
Well, thanks for having me. It was great fun.
Yeah, it was good. And how can the audience, the listeners, find you? Because you've got a podcast. What's your podcast called?
It's called Future Car Podcast with Ed Bernardon, the Siemens Future Car Podcast with Ed Bernardon. And you can find me there and talk to a lot of people in the racing and autonomous EV business. So a lot of things like we were talking about today.
Cool. Well, thanks very much.
And thank you for having me, Sam.